Now let's see how to solve this problem. There are n sets of numbers, each having only 3 positive integers. Okay, so a set basically means it will be in the form a comma b comma c. 3 numbers are there. So that's it. It can be like this, it can be like this, it can be like this. See, like this, 1 set, 2 set, 3 set, n sets are there with LCM equal to 1001 and HCF is equal to 1. Okay, let's solve this problem. First of all, they are saying that LCM is 1001. 1001 is not a new number. The same number came in the year 2023 also. If we prime factorize this number, I think it is 11 into 7 into 13. 11 into 7 into 13. Yes. If you want, you can simply divide and check also. It is divisible by 11 and 7 and 13. Divide anything. 1 time 7, balance 3 will come. In 30, 4 times, right? Yes, 28, balance 2 will come. In 21, 3 times. And this number can be divided by 11 or 13. 1 time 11, balance 3, 33, balance 3. So this is basically 7 into 11 into 30. Now we have to, so LCM is this. Interestingly, HCM is 1. So how many 3 number combinations are there to satisfy this condition? Okay, before actually solving this, let me just tell you what LCM and HCF, how to find HCF and LCM. Imagine if I number 3 numbers A, B and C. The number is 7 square into 3 square into 2 into 5 and 7 into 3 square into, or 3 cube into 2 square into, let this also be 5 square, 5 cube, and the number will be 11 into 3 raised to 4 into 2 raised to 4 into, let's say 5. If you want to find the HCF, it should be a number which is common in everything. For example, 3 is common and you have to take the lowest power, 3 square. Similarly, 2 is common, the lowest power is 1. 5 is common, lowest power is 1. So that's HCF. If you want to find the LCM, okay, if you want to find the LCM, then you have to take everything. So that means this you have to take the highest power also, 7 square into, in this thing 3 is common, take the highest power, 3 raised to 4 into, 2 is common, take the highest power, 2 raised to 4 into, 5 is common, take the highest power, 5 cube into 11. So LCM, everything will come. Now HCF, the problem is that it should be everywhere. See, for example, 7 is in 2 places, but it did not come in HCF. Okay, because it should be common everywhere. So we have to find this case where HCM is 1. If HCF is 1, there should be nothing common in all the numbers. So I can find which all possibilities are there. A, B, C, 3 numbers. I can say that, first distributing them equally, I can say that the numbers can be 7, 11 and 13. That is one combination. If you check up the HCF, nothing is common, therefore HCF will become 1. LCM, 7 into 11 into 13. So that is one combination. Now the next combination, I can make several combinations like this. Next combination, what I'll do is that, let's write this properly. HCF, LCM. Next combination, what I'm going to do is that I'll just take 7 here, put 11 here, take one of the number as 1, put 13 in another place. Here also, only 1 is, nothing is common. LCM can be similarly 7 into 11 into 13. Okay, so that is another combination, 7 into 11 by comma 13. Now all the orders, I don't have to consider the case where I don't have to take the case like 7 into 13 into 1, because these are sets, these are not ordered pairs. Therefore the order doesn't matter in a set. If the number is inside, that's it. So I don't have to repeat them. So 2 possibilities. Now again, if I just remove this 11 from here and put it over here, I'll get a new set of number, 7 comma 1 comma 13 into 11. Or if I just remove this 13 or if I just say, yeah, so that is there. Now which combination is left? 7 11 came, 13 11 came, 7 and 11, 13 and 11 didn't came. 11 into 13 1, and this can be something else, 7. So 11 into 13 comma 1 comma 7, that's another combination. Interestingly, the life doesn't end there. There are still more combinations. If I remove this value from there, put that also 1 and put 7 also here, that's another combination. That is 7 into 11 into 13, that's 1001 1 comma 1. For that number also HCF will be 1, LCM will be this thing. Okay, interestingly, it doesn't stop here. There are still many combinations. For example, the first set which we took was 7 11 and 13, right? Here also I can still make more combination. How? I simply have to just put 111 here. If you check here also, HCF, nothing is common, because 11 is only common here, it's not common everywhere. Therefore HCF is still 1, and when you take LCM, you only have to take the same power. So there is another combination which can be formed here, 7 into 11 comma 11 comma 13. Or even if I put one more 11 here, still, oh no, I can't put that, sorry, because HCF will change. Okay, that is there. Now if I remove this 11 from here and put it over here, that is still another combination where HCF is still 1, LCM is still the same. So 7 comma 11 comma 13 into 11, that's another combination. Now I can make still more variations of the same thing from the second set, from this set, that was 7 into 11 1 13. Here also, instead of this 1, if I take 11, that's already taken, right? It's already here. Okay, let's just check the answers. So right now, how many combinations I found? 1 2 3 4 5 6. I already found 7 8, more than 8. Okay, let me see if any combination, if I have mixed. 7 into 11. Oh yeah. Here, if I put, let's say 13 and 13, that's another set, right? Here also LCM is gonna be same, HCF is gonna be same. That is something which I have not taken yet. So 7 into 11 comma 13 comma 13, or I can remove this 13 and put some value like 7 into 11 comma 7 comma 13, or I can remove that and I can put 11. So that's already taken. Okay, that's one set. 1 into 13 was the thing. Now if I put 7 here, is this combination taken? 17 into 11, 17 into 11, no, that combination has not been taken. See, 17 into 11 comma 1 comma 13 into 7. Even this is a number where HCF is still 1, LCM is, yes, LCM is 7 into 11 into 13. I can even put another combination by putting 13 here. That's another combination. See, there are too many possibilities. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I already found 10, and this combination make it 11. I can still keep finding more. So of course more than 8 is there. So there are several answers for this. The problem with this problem is that many of you, after getting 6, 7 or 8, would have answered that thing. But that's a common mistake, because our brains become like potato brains in the examination hall. Don't worry about it. Now onwards you can be careful on such problems. So that's okay. Now I will give you a practice problem based on HCF and LCM. And see, the more definition etc. I cannot give in this video. Maybe one day I'll be teaching you HCF and LCM. In that thing I'll give you more explanation. For the problem is this. Okay. The HCF of 3 numbers are 2 square into 3 cube into 7 cube. LCM of these numbers are 2 cube into 3 raised to 4 into 7 cube into 11 square. And the three numbers A, B, C. The first number is 2 square into 3 cube into 7 cube. The second number is 2 raised to 2 square into 3 cube into should I okay, I'm changing something slightly. I'm making this cube in both the numbers. Yeah, 3 cube into 7 cube. I want you guys to find the missing number. Okay, so pause the video and try to find the missing numbers. This type of problems can have multiple answers. Okay, but I have limited the number of answers for this problem. The more detailed version we can see when we actually learn HCF and LCM in a separate topic. Now try to find the answer for this problem. Okay, I'm going to give you the answer. See, first of all, HCF value should be present in everything. So that will automatically come. In fact, the powers will be greater than HCF. It cannot be lower than HCF. Now, the smallest power would have came in, the HCF will be having the smallest power. Here, 2 have high, power 3 is in both the numbers. So the smallest power should have come from here. Since it is 2 here, it should be 2 here. Because 3 is the highest power which came from here. Now, see, if you look at 3, the smallest power came from both these places. But LCM have the power of 4. That should have come in from here. There is no other place. So this is 4. Now, if you look at 7, it is cube in HCF and LCM. Therefore, it simply should be cube. Okay. Now, one more missing number is 11 square. It is not here. It is not here. That means it should have come from, came from here. So the answer for this problem is this. Only single answer is there for this problem. When we see more similar problems, we will go in depth. I'll give you problems with multiple answers when we see HCF and LCM. Anyway, that's answer for this problem. Thank you.